Hi, my name is Alex Fleischman, and welcome to the video overview for the induction demonstration. Alright, let's begin this demonstration. This demonstration will introduce students to the electroscope, which will be used to demonstrate induction. Students will observe how partial charges are induced on the electroscope by induction, and how introducing a grounding wire can leave the electroscope charged. The purpose of this demonstration is to strengthen the student's understanding of induction and its applications. Alright, let's work through the procedure. First, place the electroscope on a table. An electroscope detects the presence and magnitude of electric charge on itself or other objects. Then, rub a plastic rod with animal fur. This induces a net negative charge on the rod. Next, place the plastic rod near the electroscope without touching it, and observe how the leaves move away from each other. The leaves move away from each other because the electrons in the rod repel the electrons in the electroscope into the leaves, which therefore gain a partial negative charge. The negatively charged leaves repel each other and move apart. Here's a diagram representation of what's going on in this part of the demonstration. As you can see, a negatively charged rod is brought near an initially neutral electroscope. As the rod approaches, the electrons in the electroscope feel the repulsive force of the negatively charged rod. The electrons in the electroscope therefore move downward toward the leaves. Once the electrons distribute evenly in the leaves, both leaves have a negative charge. Therefore, they repel each other. Next, choose a student volunteer to touch the electroscope, as the rod is once again brought near it. The student releases their hand, and then the rod is moved away. Observe how the leaves moved apart and stay apart. This phenomena occurs because the student is acting as a ground. Therefore, the electrons are repelled by the rod, move through the student and into the ground, leaving the electroscope with a net positive charge. Let's look at a diagram representation of what's going on in this part of the demonstration. As you can see, a negatively charged rod is brought near an initially neutral electroscope connected to a ground. In our demonstration, the ground is the student. Once the negatively charged rod approaches the electroscope, the electrons want to get as far away from the negatively charged rod as possible, and that means going through the ground wire and into the ground. In our case, it goes through the student. That means the electroscope is left with a positive charge. Therefore, the leaves are positively charged and repel each other. While the student is still touching the electroscope, move the negatively charged rod away from the electroscope. The electrons will move back from the ground through the student and into the electroscope. This leaves the electroscope neutrally charged. Let's go through some questions. In the first part of the demonstration, why do the leaves return to their original position after the rod was moved away? The net charge on the electroscope did not change. Only the position of the charges did. When the rod was moved away, there was no force exerted on the electrons in the electroscope except the force the electrons exerted on one another. This caused the electrons to distribute themselves uniformly through the electroscope such that there existed no partial charge on the electroscope. If a glass rod and silk were used in this experiment instead of a plastic rod and wool, how would the charges on the electroscope and the leaves move? Note, the glass rod will be positively charged. Well, the leaves would move apart because the electrons are attracted to the top of the electroscope toward the positively charged rod. This means the leaves have a partial positive charge and repel each other, therefore they move apart. A positively charged rod is brought near an electroscope, and the leaves move closer together. What was the initial charge on the electroscope?